Hello and welcome to our SiLA Python channel. My name is Mark Dörr. I'm working at the University of Greifswald as a staff scientist, being responsible for a large-scale robotic screening platform for protein engineering. I'm also a member of the SiLA core development team, being responsible for the maintenance of the SiLA Python repository. Before I go into SiLA Python, I'd like to give a brief introduction into SiLA. SiLA is an acronym for Standardization in Lab Automation. It specifies the communication between lab devices, but also to software, so it's not restricted to devices. Specifications are done for commands in their responses and properties, but also data transfer. It's an open license and royalty-free standard, so no further fees are required to use it. It's community-driven. We have a Slack channel, we have a Slack group, we organize hackathons like this one, and there's a nice repository of open source software at gitlab.com. Who's behind SiLA? SiLA is a non-profit standardization organization. Here's the web page. On this official web page, you can find further information about current events and the standard, so you can this is a first source to get some information about SiLA. There are around 2,000 people showing interest in SiLA and applied for the newsletter. 35 members are supporting SiLA directly, also members from academia, many lab device vendors, pharma companies, academic institutions are helping and supporting. On the left side you can see a few examples of them. It's a constantly growing community, it's very vivid, and we're very excited to develop this standard. The vision behind SiLA is to connect all devices in a standardized way, so very similar to USB, so you don't think anymore of any communication standard. You just plug in your system and it talks to another software, another device. You can build up hierarchies of larger automation setups very easily. So it's designed to address very simple devices like a balance, but also more complex devices like liquid handling robots, or even many devices in a robotic screening platform. And they can also communicate to LIMS systems, to process management systems, to databases, to electronic notebooks. SiLA is very modular. The core of SiLA specification just explains how the structure of the SiLA commands and properties should look like. Then there is a mapping, and this whole standard can be extended by SiLA features that are user specified, and by that it can constantly grow to the demands of users. SiLA is a asymmetric server client architecture. The server has the main responsible for, or is the more complex, usually the more complex part of this communication design. Within the server, different features can be specified. So a server can be divided. A SiLA server can be divided into different functional units, and within these functional units, within these features, you specify commands and properties that this module can receive or send. The whole idea is that you can reuse these features for many other servers. So if you write these features or specify these features in a more general way, then you can reuse them. Let's, for example, look at a more complex machine like a microtitter plate reader. It not only consists of a UV measurement unit, but it also consists of a door, for example, that opens and receives the plate. So it has a kind of mechanism to drive a plate in and out. It has a temperature control, it has a shaking unit. And in SiLA, you would formulate these different parts of the machine as different features. And if you have, for example, a shaker, then you could reuse this shaker feature of the plate reader within this, or with this, to describe a normal shaker, lab shaker on your desktop. The communication between control software and the SiLA server is done through gRPC. This is a very efficient protocol, and lab devices find each other by zero config. That is very similar to wireless speakers or printers in a network. They just announce themselves, and the SiLA server can find them. So there's a very config-free way of connecting devices. To summarize, SiLA is feature-based, so and by that it's very modular. It's a microservice architecture, server client architecture. It's quite by that modularity future-proof. So if an additional feature of a device is added by the hardware, by a hardware change, this can be also added as an extra feature with the SiLA command. Within a feature, commands and properties are specified. SiLA has its own data types, so it's independent of the underlying gRPC data types, and it uses zero config, or in older times it was also called bonjour network detection, to configure the network settings between the SiLA client, server and client. SiLA2 is based on gRPC as a wire format. gRPC has a large community supported by Google. It's a kind of new or improved version of REST. So it has strong type safety. The interfaces are defined by this protobuf language, so it's a very clear contract between client and server. The data is transferred very efficiently in binary form, so it's a kind of binary encoded JSON as payload, and it uses HTTP transport protocol, which makes it also very efficient. If you are looking for more information, I would highly recommend you to follow these links. So the SiLA standard.org webpage I already showed to you. Then this is this one. Then there is a Slack channel where you can ask experts or the community for help. There's the SiLA repository on GitLab, and finally there's a nice documentation also on GitLab where you can read more about the standard and also some standard features that are already specified and available. So to summarize, SiLA is a license and royalty-free open standard. It can be used for a wide range of lab automation tasks. The features can be reused, so just look at the already available features on GitLab in SiLA base. There are a lot of, or some examples where you can get inspired, or you can already use in your projects. The nice thing is that it has a multi-language support, so all the main programming languages like Python, C++, C#, Java are already supported. And always remember, open source matters. So a big community can help to improve your software, get feedback, get some nice features, and always checks that the software is relatively error-free, and this helps to make your product nice and interoperable. And by that, I would like to invite you to hear more about SiLA Python in our next presentation. So enjoy our channel and see you soon. Goodbye.